over 6,000 feet of curvature. So check it out. I understand that if the Earth were so massive we couldn't detect a curve, gravity would be a good reason to talk about how you think water's flat, but it's actually gravity, Nate. Blah, blah, blah. So at 1 statute mile, it should be 8 inches. At 2 statute miles, it should be 32 inches. At 3 miles, you're looking at 6 feet. So if you can see a grown man 6 feet tall from 3 miles away, that debunks the curvature formula right there. Not just that, you go 10 miles out, and you're looking at 66.6 feet of curvature, which I find is an interesting number. 666 has some religious significance. But let's say 10 miles is actually just 66.6 feet of curvature. That means any boat under 70 feet tall, pretty much any boat that's not a cruise ship, you can see from 10 miles out, debunks the curvature formula of the Earth. So I don't care why you think things cling to a spinning ball Earth. What I'm looking at is your purported numbers, and it doesn't match reality. So boats that are under 60 feet from 10 miles out, I've done the experiments. I grew up in Orange County, California.
And were you lying on your face when you did that?
I also went out to buy a P900, and then, but you don't understand. I could see the whole boat and the wake hitting it. And even if you calculate in the 6 feet of observer height, which my tripod wasn't 6 feet tall, but even if you did, bro, you wouldn't be able to see an entire boat that should be missing from all the Earth's curvature in between. So you're saying being 6 feet tall is going to magically make 70 feet of Earth's curvature disappear, and I'm going to be able to see the whole boat? Man, bro, that's just...
I'm sure you have a lot of math to show me why 6 feet is irrelevant. I do. Would you like to see it? Because when it comes down to it, if you are lying flat on your face while making your observation, and I'm over 6 feet tall, you would actually be very surprised to hear that, according to numbers and according to reality, welcome to reality, that actually pushes the tangent point of your line of sight back like over a fucking mile.
Okay, but the Hawaiian Islands can be visible from 100 miles away.
If you are lying flat on your face, the tangent line is literally right in front of your face. If you stand up, the tangent line moves back from you. And at 6 feet, if you're talking about a dip of 8 inches over an entire mile, and I stand up 6 feet, what's the difference between 6 feet and 8 inches? It pushes the tangent line back over a mile on using your own mathematics. Your own mathematics show that not only are you not doing the observation properly, not only are you doing the mathematics incorrectly, you're showing everyone that actually this is exactly what we would expect to see on a round Earth. So if I'm to believe that you actually know what you're talking about when you're giving me all these numbers, data points, and observations that you have done with P900 footage or pictures that you have yet to show us on the stream, then please, are you really going to blame me when I take a step back and be like, are you sure about that?
Okay, well,
no? Okay.
Let's take a look at the Chicago skyline and calculate the position of Chicago in relation to Grandmere Park, which is the photography
Please do.
Of Joshua, the one that famous picture that got on the news, and the newscaster actually had the audacity to say, "What you're seeing here is a mirage." Gotta love those globe Earth priests. So Grandmere Park is 600 feet above sea level. Lake Michigan is 577 feet above sea level. So Grandmere Park is 23 feet above Lake Michigan. So let's assume the photographer was at the highest point in Grandmere Park, and then let's add 6 feet for the height of the photographer. We come up with an estimate that the camera was at mere 29 feet above the level of the water of Lake Michigan. So we will subtract 7 miles from the distance of 57 miles to account for the 29-foot elevation of the camera above Lake Michigan. So calculating the curve of the Earth using the 50-mile distance, we find that street level of Chicago should be 1,644 feet below the horizon. The tallest building in the picture is the Sears Tower. The Sears Tower was from 1974 to 1998, the tallest building in the world, stands 1,450 feet tall above street level. However, the antenna on top of the tower brings the total height to 1,729 feet above sea level. So we're seeing all that, and it should all be gone behind the horizon. So I find that very interesting. And that took into account the height of the photographer, which is very easy to do, bro. You just plug in the numbers. You're smart. You know how numbers work. Putting in a 6-foot observer is not impossible to do. Just grab some AutoCAD. If you don't know how to use AutoCAD, I got a buddy who's an engineer in New Hampshire, Joshua James Palermo, and he'll show you how to use AutoCAD.
I really do appreciate that, but I actually have a different request. If you can please bring up objections that I haven't debunked on June 18th of 2015 going over the Chicago skyline observation. Let's go over it, shall we? So here we have the Willis Tower. It's no longer called the Sears Tower, by the way, just a little bit of point of fact. We actually go over the complicated geometry and go over the numbers and plug in exactly what we need to plug in order to find out how much of the tower should actually be hidden by the horizon when we're looking at this image. This is the image that you were referring to, the Chicago skyline mirage image. We took a look at the number of floors, took a look at its height, took a look at what the difference would be when it comes to the hidden by the curvature, which would be 56 feet in this case. And we were also trying to figure out that at value would the atmosphere actually have to influence the light bouncing off of the Chicago skyline in order for us to actually see what we were seeing in the picture. And when we go through the math and we see, what we need to see, blah, blah, blah. So let's go ahead and do a little bit of trigonometry. If you don't know trigonometry, I know a good guy that can help you out with that. And going through trigonometry, we see that we have a refractive index of 2.76. The refractive index of 2.76 actually gives us a value of 0.12 degrees. What this means is that the light from Chicago skyline, in order to be observed from the observer from across the lake, would be 0.12 degrees. Are you telling me that the atmosphere, being a liquid medium, cannot influence light by 0.12 degrees? That is a pretty heavy burden of proof to bear. But hell, if you can prove it, I'll believe it. So please tell me, is it impossible for light to be bent by the air by 0.12 degrees, where even Flat Earther agrees that things like atmospheric, distortions actually do happen? That's diffraction, deflection right there, admitted by other Flat Earthers. Are you going to disagree with them now? 0.12 degrees. How do we explain how it's impossible for that to actually be an influencing factor?
Red, the whole entire skyline should be behind the curvature of the Earth. So I don't understand what you're talking about, light and 0.012 degrees. The whole thing should be
That means atmospheric. Then let me explain, because obviously I was not clear.
The atmosphere is magically bringing the disappeared horizon around the curvature of the Earth? Is that what you're saying?
So wait a minute. Are you saying that light traveling through a medium and being influenced by that medium is magic?
No, I already told you that's why the sun doesn't shrink. So I'm just trying to understand why you think the entire skyline should be visible.
So it only works. I get it. I actually think I get it now. So the atmosphere can influence light only when it supports the flat Earth, but when it supports the round Earth, then we have to negate it.
Is the skyline a light? We were talking about lights, and it's very well known that when lights are being shown through a dense medium, they increase the size.
Oh, okay.
So unless the skyline is a light, I don't know how this...
So when you're observing the skyline, are you observing the skyline directly, or are you observing the light that's bouncing off of the skyline? I'm wondering on how well your understanding is here.
You're looking at the skyline.
But not the light that's bouncing off the skyline.
It's not a mirage, okay? You're seeing the objects that are in front of your face, and those objects should be behind a curve, but there's no curve, so that's why you can see them.
Okay, so basically what you're telling me, just to make sure I understand you're saying light is completely irrelevant when looking at objects.
No, not at all. Not at all. And the air actually, the air actually plays a part too, because if the air is denser, and that's
let's focus on light. Let's focus on light.
Sometimes you can't even see across the street because the air is so dense and so foggy. But so what are you trying to say, Red? I'm still trying to follow you on why we can see the entire skyline when the entire skyline should be behind the horizon.
Actually, a point of correction there. We actually couldn't see the entire skyline. 646 feet of it was actually hidden, and that is observed in the picture. I can go over the video again if you want me to. But of the portion of the skyline that we can see, the portion of the skyline we can see indicates that the atmosphere would have to influence the light bouncing off of the Chicago skyline by only 0.12 degrees over 55 miles of atmosphere. Because you're dealing with that much medium, you have a very small influence is actually possible. You having a very small influence, given the fact it has 55 miles of the shit to go through, is not only possible, it's what should be expected in some cases. And in that particular instance, when that picture was actually taken, it shows up. Not only that, but I also want to point to one thing that picture also tells us, and that is the stretching of the image. If you superimpose a picture of the Willis Tower right next to the Willis Tower that is shown in that image, you will see that the proportions are completely different. The reason why the proportions are completely different is because the image is being stretched by the atmosphere. That stretching meant it stretched over the curve and allowed us to actually see it. What was the rate at which it needed to do that? 0.12 degrees.
So atmospheric magnification is
atmospheric refraction. Atmospheric refraction.
Well, you're saying it's making it larger, it's expanding it. So that's
no, stretching. It. No, stretching. Stretching is not magnifying.
It's getting bigger.
No, taller, not bigger. Taller, right. Not bigger. Taller.
It's getting taller, so it's stretching it out, it's not magnifying it. It's atmospheric. So
I can explain it again if you want me to.
So the air is making the building taller. All the buildings, or you can see.
Not the buildings. The light bouncing off the building is being refracted in such a way as to make it appear over the horizon.
So it's
itself is the photons being influenced by the atmosphere they're flying through. It's the photons being influenced by the atmosphere that they are currently dealing with.
So the light is curving around ball Earth and showing you almost the entire skyline besides a few hundred feet at the bottom, which, I mean, is just atmospheric magnification. You shouldn't expect to see street level from 50 miles away. That's ridiculous.
Well, I would, again, correct you, atmospheric refraction, but at this point, it's semantics. So if you want to call it magnification, be my guest, but just know my definition of it.
Cool. So yeah, my claim was the entire thing should be behind the horizon. I'm not convinced that light is bending around the curve of the Earth and stretching out the buildings, and that's why you can see it. I just go with, what's the most logical. And just like I mentioned before, water has 1,700 feet of hump in the middle of the lake. That's just ridiculous. It puts a giant smile on my face that people actually believe that nonsense. But it's not what we see in reality. Lakes freeze over.
Even though we have a picture of it, we don't see it in reality, but we have a picture of it.
You have a picture of a lake humping? I would love to see that. Pull that up on the screen.
Sounds like a plan to me. Let's go ahead and do this. All right, screen sharing in 3, 2, 1, and let's go ahead and bring this back up.
A frozen lake. Oh, you're going to go to that one lake, the same one that you used before?
Do you like? Hang on, question.
You haven't been there.
Hang on, question. I have a question for you. Do you prefer moving pictures or still pictures? Because I have both. Which do you prefer? This is a moving picture.
First-hand observations, that's not first-hand, but also, like, it's very easy to fake moving and still pictures. So I don't know why you think that.
I would love for you to prove to me that this is fake. I would love for you to prove to me that this is fake, considering it's been done multiple times by multiple people.
Multiple times? Well, show me more than one video, Red.
This is the second. Oh, sure. We have, let's count the videos. All right, so we have 1 video, 2 video, 3 video, 4 video, 5 video, 6 video. Hang on. You asked me to count them, so I'm counting them for you. So what was I? 8? So we have 9 video. This is a
that all looks like
GIF
the same
or
video,
whatever.
Red. You're counting multiple of the same video. So.
And 10 video. Well, this one's no longer there, so I won't count that. Let's see. Okay. All right, so this is the end. So I would say about 10 videos of this one spot on different days that you can see actual curving